Let's talk about the PV module selection tab. The database of PV-Sol contains many models and brands of PV modules. You can select a company, then select the module. Here, you can see information and data about the module provided by the manufacturer. You can limit your selection to only include favorites we have selected before. We have two methods to enter the number of modules and their orientation. Firstly, DDI or direct data input, and secondly, through graphic coverage by making a 2D model. Let's start with the DDI model. Concerning the number of modules, you can simply enter the number or let PV-Sol calculate the number according to a defined consumption. Desired generator power is the output power of the PV panels or modules at their peak all together. kWp stands for kilowatt peak. If we choose 20 kilowatt peak and we selected a 200 watt panel, then we need 100 panels as 200 watts is their peak, then we need 100 panels to give an output of 20,000 watts or 20 kilowatt. Another method is defining how much of the consumption will be covered by the modules, and it's a percentage of yearly consumption or certain months may be the lowest months in terms of energy. How the kilowatt peak could be calculated according to kilowatt hour you entered in the consumption. We enter 2000 kilowatt hour, then the average daily consumption is 2000 over 365 equals 5.479 kilowatt hour per day on average, then divided by the peak sun hours. The peak sun hours refer to the solar irradiation a location could obtain if the sun were shining at its peak for a certain amount of hours. Since the peak irradiance, which is STC, is 1000 watt per meter square, the number of peak sun hours is a representation of the average daily solar irradiation or insolation. So, back again, 5.479 kilowatt hour from a consumption divided by peak sun hours average, which is nearly equal 6 hours in a certain location, maybe Egypt, and it's different along different locations for sure. Then it represents 0.91 kilowatt peak, means that if the panels work for 6 hours of maximum sunlight, then they would cover all of the daily needs. If we need 65%, then it's 0.65 multiplied by 5.479 over 6 peaks and hours equals 0.6 kilowatt peak approximately, and we need 3 panels. If you need, for example, 0.9 kilowatt peak and each panel is 200 watt, then to get the number of panels, we divided the power over the power of each panel. So it's 0.9 multiplied by 1000 over 200, 4.5 panels. PV-Sol would round it to the greatest, which is 5 panels. The inclination is the tilt angle of the PV module. The orientation or azimuth represents the angle of deviation of the module from the south. We can say that if the panel is 0 degrees azimuth, then it's due to south with orientation 180 degrees. If it moves anti-clockwise, the angle is negative. Clockwise, the angle is positive. Then due to west, which is 270 degrees, the azimuth moves 90 plus 0, which is 90 degrees. Due to east, the azimuth moves 0 minus 90, which is negative 90 degrees. I usually use the solar atlas to recommend the optimum tilt angle and the optimum orientation to get most out of a fixed panel. If most of the load is from 8 a.m. to 9 a.m. for example, we have to move the panels to the east a little bit to capture more energy if we are in the north hemisphere, as the panel will get more direct or normal sun rays. You can see sun rays pass here, see the orientation and the elevation of the sun in the sky in June solstice, December solstice and the equinox. If the load is maximum in the morning in summer, then you work here, get the average orientation angle from 8 a.m. to 9 a.m. and set the panel to it. If we see the average between 50 and 90 degrees, it's 70 degrees, so you set your panels at 70 degrees to get the most out of it. Same goes for the tilt or the elevation angle. The horizon represents shade by the terrain or mountains, or the topology of the earth at the location. Then you choose the installation type. If the panels are mounted parallel to the roof and have very good rear ventilation, or it's a part of the roof but there is very small space to rear ventilation, or it's mounted using a chassis on an open area or on a roof. Additional parameter increases the accuracy of the model. If you have information about some losses, as the losses caused by the voltage drop as a bypass diodes, most times it could be ignored. When connecting different panels, the overall power from the two will usually not be the same as if they were at their peak, due to different MEBs or maximum point tracking of the two and different point of operation. The value is often from 1% to 5% at most. The albedo is the ability of a surface to reflect sun rays. If the percentage is 0.9 or 90%, it indicates that the surface or the ground material reflects 90% of the falling sun rays to the PV panels. We can say that the snow reflects most of the rays fall on it, so it can be captured by the solar panels. If there is snow in January, you can set it to 90%, or according to the terrain or the surface you put your PV in. Normally, the albedo is 20% when there is no snow or there is no special conditions. Soiling losses is losses due to accumulation of dust and particles on the panels or module surface, blocking some of the sunlight. Most of the times it could be ignored. You can set the parameters to default if you don't have any information about those parameters.